Hi, at Twingate, we're looking to provide a lightweight approach to implementing zero trust as we move away from physical networks being the center of gravity to more of a model where user identity, device trust, and context are incorporated into securing remote access.
Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Best Practices for Secure Infrastructures as Code Initiatives, brought to you by Twingate Inc. Joining me today is Alex Marshall, co-founder and chief product officer, Twingate Inc., and Lior Rosner, co-founder and CTO, Twingate Inc. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
All right, hi everybody. So I'm really excited to go through this with you, and what we're going to run through is a bit of history on why this is important, especially what we've been seeing from our customers, and end with some examples. Hopefully you guys will have some good questions ready for us at the end as well. So Twingate is a zero trust access product, and a lot of our customers have been moving from more sort of like legacy architectures for access. Namely VPN. And what we want to talk about is sort of how that integrates, really nicely with infrastructure as code initiatives internally. So let's run you through this. So how we see the world and how our customers perceive things and have been working with us is that the reality is that over the last 20 years, things have been changing pretty significantly. So cloud, mobile, and of course, like remote work in the last 18 months are really like pretty new concepts, right? So 20 years ago, largely like most employees were in the same place. They had largely static machines, largely static resources, which were often actually in the same place that they worked. So with all these shifts that have taken place, there have been a lot of shifts around like how companies have been managing infrastructure, and those changes have been taking place. But what's largely remains is somewhat static, but is changing is how they approach security in these more dynamic environments. So let's talk a bit about why we think that this is so important, and why particularly now it's important to be talking about this. So the first thing is that most companies today have some kind of distributed infrastructure. It's very rare that businesses have infrastructure that's located in one environment, on one network, in one physical location. So that presents its own types of challenges for how the infrastructure needs to be managed and secured, and how you provide access to that infrastructure. Not only is the infrastructure distributed, but as we'll talk about in a second, the people that are accessing the infrastructure are also in lots of different locations. And so you have some pretty unique challenges that you need to deal with. The second thing is that we generally work with some of the sort of fastest growing sort of tech companies in the world, and so we sort of see the sort of like leading edge of some of these changes that take place. But I think we'd say that probably the vast majority of those companies do have some kind of process in place for infrastructure as code. So this is a pretty commonplace practice now, and the benefits are pretty clear in that you can now declaratively define exactly what your infrastructure looks like, where it's deployed, and making changes is really easy. Which leads us to the next point, which is that the access part of this equation, which typically is a VPN, is really lagging, right? So VPNs are not that easy to deploy and manage, and rarely can be managed programmatically. So some other trends that are sort of affecting all this is that there's an increase in security risk. So it probably can't go by a month without hearing about some major breach, and it just underscores the importance of taking this really seriously, because otherwise you're really just sort of like gambling that someone won't find you. One of the big issues with sort of legacy access, particularly via VPN, is that the entry points are public. And it's fairly easy these days to do sort of internet-wide scan, find that public entry point, and then look for vulnerabilities. Lastly, the way that people work is changing. So a lot of this was sort of already happening over the last 5 to 10 years, but what's really happened with the pandemic is that those changes have been accelerated. So there probably isn't a company that hasn't been or hasn't had to take like a really close look at what their sort of remote work practices are. But I think that on the other hand, I think it's been shown that people can work remotely, and the question is, how do you best manage that, ensure that the right security is in place, and that employees are, satisfied with sort of the level of access and performance that they're getting. And so better solutions, clearly do exist today, which brings us to the next section. So, just to tell you a little bit more about, who we are. So, you've got two of the co-founders of TwinGate on the call with you today. But we have, pretty long backgrounds in building, well-designed or like thoughtful B2B products. And we're really, really passionate in this area about bringing, thoughtful design to an area that I think has been lacking it for some time. And many of our customers, are some of the fastest growing companies in the world. And so if you're listening to this call now, you likely have a lot of the same problems that they have, and maybe if you don't, you will in the future. And a lot of these companies are really trying to deal with situations where they've got that situation with distributed infrastructure, access hasn't been keeping up with that. Their workforces are rather distributed and remote, working lots of different devices and locations, and they're really trying to figure out like how they can best manage like all this change that's been happening and set themselves up for the future. So what I want to cover next, like on that note, is a little bit about a sort of little history lesson of how network infrastructure in particular has been evolving. And this is something that we've seen, from the founding of TwinGate through, it's ringing true today to what our customers are dealing with. So as we mentioned sort of before, the old model really was, pretty dominant until relatively recently, which is that companies largely had one network segment or maybe a couple in one physical location, and everything can be managed centrally. So it was actually pretty straightforward to manage access. And the sort of analogy that we draw is a little bit like physical security, right? If you were allowed into the corporate headquarters office or one of their subsidiary offices, then you're allowed access to the network. And so it was relatively easy to secure things. And for the employees that, relatively rarely in the beginning, but more commonly as we come to the present day, needed remote access, then you simply set up a VPN, right? And that was your entry point into the network. So over time, like things have really changed, right? So not only are there, lots of different, services that people need to access, whether they're SaaS-based or public cloud, or private cloud resources that are set up by companies, but those resources are also located all over the world. And so the landscape has like really significantly changed. And not only is the infrastructure all over the place, but so are the users, right? So you now have, especially over the last 18 months, you have people working from all over the place, and what people have been relying on is still this sort of like old model. And so what we need is something that's more that an access model, a security model that's more distributed by design, which matches how people are actually working. So what I want to do is just go into that in a little more detail, to underscore what the implications are, and I think this will help clarify like what some of the worked examples are that Lior will run through in a bit. So in the sort of new world, but with sort of old technology, most companies that we speak to who are still using sort of VPNs, like this is what we're showing here on our slide is really what their experience is. And so their experience is that they still have this sort of legacy VPN set up on the corporate network. Now, it doesn't necessarily have to be via the corporate network as is shown in the slide, as I'm sure you're aware. But oftentimes, like there may be several VPN entry points into some of these different networks, but the commonality is that the infrastructure has to accommodate the access method, right? And so the VPN gateway becomes this entry point, as is shown in the slide, where all network traffic flows through that gateway, through that network segment that it's attached to, and then on to other network segments. So there's a few issues with this, right? Which is, one is, as we mentioned before, that VPN gateway sits on the public internet, which that's just how VPN works, which means that it becomes a sort of public attack surface. Performance is obviously not very good, and it may be acceptable, but it can certainly be better than by routing traffic, across network segments. And from an infrastructure management standpoint, what it means is that you then have to manage all these different, routing rules. You have to manage, peering between different networks. Debugging can be pretty complex when trying to understand, why certain things are accessible and others aren't. And so it just adds a lot more complexity into the picture to run a network like this. Um, the other problem is that it's not really stepping away from that old model, right? So there's still like an implicit assumption here, which is that there is a certain network entry point that's considered safe, and that traffic's allowed to flow between segments once it's arrived on that initial one. Right. So these are some of the problems we see today, and a lot of the customers are speaking to have sort of been suffering through this and are looking for a better solution. So there is a sort of a middle ground, and this is over the last 10 years or so. There have been a number of solutions that really sort of are cloud based, and do solve some of the problems in terms of centralizing access rules for who has access to what. Probably better logging and addition of additional security tools, but it still doesn't really solve the infrastructure problem. So at the end of the day, this central service, if you're running it, still acts as a bottleneck, right? Because all sort of remote user traffic still flows through this central point, and that central solution still needs access into individual network segments. And so how you set that up, there's a variety of ways to do that, but largely you're still only solving sort of like half the problem. And what we want to get to, I think, is a more integrated solution where users should be able to access each individual network segment that they're entitled to access directly, right? So you want to eliminate the situation where traffic is being routed through any central bottleneck, whether that is a VPN gateway, that you're hosting, or a cloud-based solution. And so the sort of more integrated model with IAC is a model where the access is actually integrated into the deployment of the network itself. And so that's sort of what we're showing here, which is that in those public cloud networks and even that corporate network, there is this entry point, which in our technology is called a connector, but other products have different names for it. And that entry point is simply a piece of the network infrastructure. And so that means that when you're deploying things, and changing configurations and managing access and bandwidth and so on, that can be done sort of in the native language of IAC. And then, of course, there's other like ancillary benefits, right? So from an end user standpoint, their network path is direct from their device, wherever it happens to be in the world, direct to that network, right? If access is entitled. Access, speaking of which, is managed centrally, right? So not only can you, through IAC practices, deploy access directly into the infrastructure that you're managing and maintaining, but you can actually also synchronize that back to the access rules that determine who's allowed to access those networks. So overall, like we see this as, clearly, I think a more approach that's sort of more aligned with how infrastructure is managed today and how people work today, and it has a whole host of benefits. Okay, so I've already started covering, I think some of this from the access and security standpoint. So I just want to drill into this a little deeper, and then that'll set us up for going through a few examples, which Lior will run through. So just to sort of underscore the point, so they're really in the sort of like the legacy world. You had to work with sort of like two primary restrictions. So the first is that it's not that simple to deploy a new VPN gateway, and so you end up with a limited number of sort of ingress points into your network. So that's the first point. The second thing is that it actually it used to be relatively difficult to reconfigure existing infrastructure, and so a lot of this we'll go into some detail here. So a lot of this came down to some of the old problems came down to the fact that you're restricted by VPN, right? So as I talked about before, with that limitation there with ingress points via VPN, is that again, like, network had to be routable between network segments, and maybe it wasn't routable between all network segments, but the burden was then on the infrastructure team to make decisions alongside the team that was managing access as to what network traffic should be routable where. And I think, as I'm sure many of you have experience with, like this leads to like very complex, not only routing rules, but also firewall rules, logging, trying to determine what IP address is associated with which user, and so on. So it's just very difficult to manage in the first place. The second thing is that from a security standpoint, when you start merging these different network segments, even if you do have some limited rules, if there's any ability for traffic to move between network segments, you do have an issue with, potentially have an issue anyway with lateral movement, right? So if an attacker is able to gain access to any network segment, there is an opportunity, if there's any exploits or misconfiguration, that they're able to take advantage of to actually move between these different network segments. And so that generally increases the blast radius for any potential attack that may happen. So then on the second point, it's pretty difficult to move these things around. And so a lot of the sort of pain that we've been hearing is that if you have to go through a network infrastructure reconfiguration, it became, a second project to also figure out like how do you actually reconfigure, your access via VPN. And so again, it's just VPN solutions as in general just aren't very well integrated into IAC methods, and so it does become more difficult. That doesn't mean all of them aren't, but it does become much more difficult to move things around. And then also, as we just talked about, as you're moving those ingress points around, you then also have to update all the different routing rules and sort of firewall rules between those different network segments. Right? So overall, just a lot more work. Right? And so I'll just talk about the ideal solution before I hand it off to Lior here. But from an ideal standpoint, right, access needs to be declarative, and the second thing is that access needs to be decoupled from infrastructure. And so I'll say a little bit more about again how we see this. So from a declarative standpoint, as I was just mentioning, the infrastructure itself, right, which is already declarative from via an IAC solution in terms of what's deployed and where, is that access needs to fit in with that. And so there's two components to that, which is one is what is the component in the system that's allowing your users to gain access into that private network. And two things, like one is, can it be deployed by IAC? And then the second question is, how can those rules about who should have access to that system be declared programmatically as well? And if you can satisfy both of those conditions, then you end up with a situation where, as you change infrastructure and maintain infrastructure, make other changes, is that the access question doesn't become a second project. It's actually natively integrated into the way that you're managing the infrastructure itself, right? And that brings you to the second point. So one of the again, one of the other problems that we've had our customers raise to us is that one, their desire to create sort of like an ideal infrastructure environment where there's proper segmentation between different environments, and that really taking account sort of like best practices around security, that those needs have often been undermined by the need for access. And so ideally, those two things are entirely independent. So you should be able to sit down and design your perfect infrastructure from the standpoint of what makes sense from cost and performance and security standpoint, and not actually have to worry about making any compromises or modifications just so that people can gain access to that environment, right? So if you can separate those two things, then you can sort of satisfy both needs. Okay, so what I'm going to do now is hand this over to Lior, and then we'll walk you through a couple examples. So over to you, Lior.
Thank you, Alex. Yeah, let's start. So before we drill down into a number of typical examples that we see with our customers, let me just highlight a little bit of when you are looking for, let's say, a new solution for your accessing your private resources, what should you focus on? So you definitely want to focus on solutions that are very much aligned with your recent trends around infrastructure as code. You want to be able to make sure that since your infrastructure is dynamic and you want to control it with the infrastructure as code, you want to make sure that your remote access solution complies with that too. You want to make sure that you are able to deploy every time you update your infrastructure, you are able to update the rules that govern your remote access solution, right? So we've seen that coming a lot in many cases with when we talk with customers that those are typical problems. Let's take a simple example to start with, just to make sure that we are aware of how does it look today when you deploy a VPN, and how does it look when you deploy a new edge remote access solution. The terminology I'm using here is AWS bound, but like it's very, very typical with any other cloud provider that you use. I try to use it as the generic terms as best as I can. So the top example is a typical VPN solution. We have a simple one VPC. Usually we'll want to deploy an internal DNS to enable access based on resource names instead of IPs. You need a NAT gateway usually on that network to allow internet access, egress access to your subnet. And you will deploy in AWS terminology a client VPN endpoint that will allow you to somewhat expose your resource. In this case, I have an instance here, and you have a VPN client that will allow connect to that client VPN endpoint and will allow traffic to flow from client into the VPN endpoint and to your VPC subnet and instance. Very, very simple and straightforward when we talk about those simple cases. With zero trust solution, it will be very, very similar on the simple side, on the simple case. The main difference here, if you can see, it is a little bit subtle on the initial simple example, is that the connector resides inside the network, inside the subnet, and we will see how this solution allows you to scale better as the scenario becomes a little bit more complicated, right? So before we go into let's say the zero trust solution, let's see how a VPN scenario scales. Okay, so this is similar to our initial example with VPN, but now instead of having two VPC, one VPC, we actually have two, which is very common. Let's say a simple separation between your production VPC and your development VPC, right? So what we did here is somewhat typical. What people would do would actually duplicate the same architecture, right? They will expose another client VPN endpoint, one for production and one for dev, and it looks very, very similar to how it looked in the previous diagram, but now everything is double. The nice thing about it is that you gain really good performance. You go from the client directly to your destination, which is nice. The network is relatively simple. We'll see with other example where the network is getting a little bit more complex. Right now, those two environments are completely disconnected, which is good in terms of security. You can enforce, when you do deploy new instances, you can theoretically also upgrade the VPN endpoint rules because they are more or less related to the same location. The problem with it is that first, from user experience endpoint, from user experience point, you cannot be connected to, you should choose where do you want to be connected to. Like with traditional VPN, you either are connected to the production environment or you're connected to development environment. You can definitely not be connected to both at once, right? So that will require you to constantly switch between. And if you have something that you need to access in parallel, this is not an easy task to do. So another very common practice is to do something a little bit different. This is this is also documented on the as an example on the AWS client VPN documentation. Instead of having 2 VPN endpoints, you only have 1. And what you do in order to enable access between the different VPCs is use a different type of connection, which is there are different types of those. All of them are like some type of VPC peering. This allows you as a client to connect to one endpoint, and then if you want to access production, it will be very similar as you accessed before. If you want to access the development, the client VPN endpoint will tunnel the traffic through the VPC peering into the dev VPC, right? So what's the problem with that approach? First of all, you see we are holding the traffic between 2 VPC. If they are very close, that's great. If they are in different locations, that means you will suffer with a significant delay. That's one thing. The second thing is it's typically very hard to manage because on the previous slide, the network were completely disconnected. Here, you need to bridge them. So when you bridge 2 networks, you need to be very mindful regarding IP addresses and how do you, the routing tables and stuff like that. It makes everything a lot more, let's say, more fragile. And sometimes it's not even an easy task to do, because if you want to bridge 2 different networks that are coming from let's say different vendors, even like you have a subnet in GCP and one in AWS. Now we need to make sure you have some kind of alignment across your global network. The other part is that what happened right now is that this client endpoint VPN, which is probably, if you deploy it as an IAC, you want to deploy it as part of this production subnet. Now the rules enforcing your access to your development instance are probably need to be enforced somewhere around the production, which is seems like not a good separation of concerns. Ideally, what you want to do is make sure that you deploy your production rules as part of your production infrastructure as code, and when you want to deploy your development rules along with your development deployment. But in this case, it's going to be hard to implement it, right? So that's the second, I would say, example. I would even say that in most cases, most of the customers that we see are using either the first example or the second, or some kind of a hybrid of both, because usually you don't have 2 VPC or 2 network, you have a lot more, right? So it's getting really, really complex, really, really fast. It's very, very hard to scale in those type of solutions. The last example I would like to show you is the zero trust model. So the zero trust model scales the same way as it scales for one network, it scales to n network. First of all, you deploy your connector, which is a typical, not a proprietary component that looks different on AWS or looks a little bit different on GCP or Azure or whatever, you deploy like a typical VM or a Docker instance. You can deploy it on every type of cloud, right? So in this case, we have 2 VPCs in AWS and 1 in GCP. It doesn't really matter. You don't have to pair the networks at all, right? There's no connection between subnets here. You can if you want, but it's not required in order to facilitate access to those private resources, right? The connector by itself is the component that enforces the rules. So you can deploy the connector together with the rules. So once you deploy production, any resource to production, you can deploy upgrades to the rules to the connector for production. Once you do it on different subnets, different environment, you can do it separately. You don't need to have one entry point. And the last piece is because the infrastructure is aware of the resources and where they are located, you are able to use a client that will do the initial routing into the subnet. And this will allow you to be connected to multiple networks at the same time, which gives like significantly better user experience. Okay, I think we're done. Alex,
all right.
any questions?
Appreciate it. Yeah, so we do have some questions. So feel free to submit some more. So we'll start going through these, and maybe that'll spark some more questions. So the first question we had was from Vasanta, which is more secure from a VPN standpoint? Is hardware based or pure software based VPN more secure? So I would say, we're a little biased, right? But I think that the answer would be neither. But I think that the point is, I think, of course, there's like trade-offs in hardware and software. It depends what vendor you pick and that kind of thing. But I think from our standpoint, if you're just thinking about this, like from a security standpoint, I think what we see is like the biggest issue with VPN is that the technology requires the VPN gateway, which we sort of intentionally in this slide put right on the boundary of that corp network. It requires a VPN gateway to be public and have a public IP address. And so as you may or may not be aware, it's actually pretty easy, especially with IPv4, to scan within 10 or 15 minutes every single IP address on the internet, every single port, and then look for VPN gateways. And what attackers do is that they look for VPN gateways, and then they test like known vulnerabilities on those VPN gateways to see if they can gain entry and access. And so I would say, like, whether it's hardware or software, like that is like a major failing of the technology that's really advertising that entry point. Anything else? Yeah, Lior, just chime in if you want to mention anything else. But yeah,
that's great.
Okay, great. So we got let's see, we got looks like 3 more questions here. Okay, so we have Mike L. There's 2 Mike L's. So this is the first Mike L. He says, I've been told that IPv6 solves all the problems of placing resources on the internet and securing them with a firewall, simply. Can you talk about how IPv6 changes the picture from IPv4? So this is a pretty interesting topic. I think it's a really rich area for exploration. It's interesting. So I've been hearing. So we worked at Dropbox a long time ago. We had a bunch of customers that asked us about IPv6. This was about 10 years ago. And in the intervening 10 years, as we've been talking to, again, a new crop of companies that's tackling some of these problems the first time, it's remarkable like how few are actually using IPv6. And so that's not to say that there is some promise there, because I think the question is right, which is I think that there is a really different model for providing access. And I think there's two things that come up. So first of all, like one of the things that IPv4 has introduced is this need to sort of like segment off these private networks, because not everything can have a public IP address, and that's led to the development of technologies like NAT and so on. But I think part of it is IP scarcity. I think the other problem is that I think from a security standpoint, it feels better to have a sort of like wall around your private resources. But But I do think like for our product in the future, I think one of the things that we've been sort of thinking about and watching, it really I think does require better adoption of IPv6 is for the model where, if I move over to the slide, sort of like the modern architecture, I think for this model, we're doing a lot of like fairly low level, I think what we would say are innovative things to basically get the user from that client software running on their device to the connector running the remote network, and doing that in a secure way. I think IPv6 in the future does open up methods to do that more simply, and still apply like a pretty narrow and controlled set of authorization access controls for users. So that's how I sort of see IPv6 sort of impacting us going forward. I don't know, Leo, down here, other thoughts? It's a pretty open area, I would say, at the moment.
Yeah, I totally agree with everything you mentioned. I think IPv6, first of all, there's a big adoption issue here. Definitely with IPv6, it will allow new solution to emerge. I still think that the part of identifying who's accessing the user, the device, and the destination, regardless whether it's an IPv4 or IPv6 or a DNS address, this is still things that needs to happen behind the scene as part of a zero trust solution. And they are kind of unrelated to the IPv6 or IPv4 usage, right? So yes, IPv6 will simplify some stuff, will allow us to do new stuff, but still, I think a lot of what we are talking about here today is not exactly directly impacted. The same problems exist with IPv6 too.
Yeah, exactly. And I think, I think we're all waiting for that day when IPv6 is a standard. It does make a lot more sense, and does make a lot of things easier. I mean, one of the problems, of course, that customers deal with is that their different private network segments often have the same IP ranges, which generates its own set of problems. But yeah, Leo raised a good point, which is that I think that there's another benefit to sort of like this like future model, and that speaks, I think, to some of the ways that people are configuring Terraform, which is that you no longer are really relying on IPs to identify users. And so as far as like using Terraform or other IAC practices with our product as an example, what those companies are doing is identifying who should have access to what based on their identity, which is their corporate, generally is their corporate email address, as opposed to their IP address or something else. Okay, so let's go into some of the other questions here. So there's another Mike L, coincidentally, and so he had two questions here. One was, can you describe the connector in more detail? And then secondly, so that's why I have this slide up here right now. And then secondly, how does the client choose the right connector? So maybe we'll take like a first pass of this. So the architecture is like pretty different in the sense that in the older model, if you were allowed to access the VPN, that was just decided beforehand. So you're allowed to connect to the VPN, and then from there, it's up to the internal systems to decide like where your traffic is allowed to go. In this case, what we're doing, and this is specific to us, but there are other technologies that do this. This is like a generalized, more bit of a generalized solution for this sort of new zero trust model, which is that ultimately the goal is with zero trust is to say that when the user is attempting to access something, is at that point in time determine whether they're allowed to access it. I mean, one of the things that we do that's fairly unique in our technology is that we decide that at the actual endpoint, right? So the client there is making a decision about whether the user is allowed to access something or not. So that leads to a lot more efficiency because the decision is made locally. And so what we're doing there is to answer the second part of Mike's question, is that the client is deciding where that traffic should go based on what resource that user is trying to access. So in the example here, if someone is on the engineering team, they're trying to access admin.co.int. The client knows there's more complexity here, but it knows that ultimately the right connector to connect to is the one on the corporate network, and from there traffic is routed. So that's sort of how that works. And then the connector itself, you can look at sort of like the client and connector as the sort of the bookends to a proxied connection. And so the connector itself is really just a reverse proxy that sits behind the network. And we probably don't have enough time to go through this right now, but there's a number of sort of like methods that we use to ensure that the connector is behind the firewall, does not require any open ports or anything for the client to gain access to it. And then the connector is responsible for enforcing rules about who, it's sort of like a mirrors a client, but enforcing rules about who is allowed to access what and where that traffic is allowed to be routed to. All right, did I miss anything? I think we're good.
Yeah,
okay.
Great.
Okay, so all right. Okay. Let's see. So we got maybe like a few more questions here. These are coming in. These are great questions, guys. Results of effect from over automation. I'm actually not. See, so we're just trying to parse these live here. Multiple machines. So one question here is maybe Lior, you want to see if we can jump into one of these. So it says like, so Vincent's asking, how do you make sure you minimize errors when dealing with multiple machines as a result of effect from over automation?
Yeah, I'm not sure I understand.
Yeah, we're happy to answer your question, Vincent. Maybe you could clarify what you mean by over automation. You can send over another question. That's fine. Okay, so Vladimir is asking. He says, seems I might have missed something. You note central management VPN systems is a downside. Can you elaborate? So I think what you're referring to, I think is like this sort of like intermediate picture. So I think that there's maybe like 2 points that I'll make in terms of sort of clarification. One is, I think for the sort of like the central VPN management solution, or the hosted VPN management, hosted VPN solution, is part of this. The issue here is you still have this bottleneck. I think that's the number one thing. But actually, I think maybe more relevant, like to this session, is really, I think what we're driving towards is in this sort of like idealized model. Or if I actually go over to, if I can actually get to this slide over here, give me a second. If I go over to Lior's third example, I think what the most relevant thing is from an IAC standpoint is that everything is like completely declarative. So in this model where we have like 3 different subnets where we want to give access to end users, of course you don't have to give access to every subnet. So you can decide as you're reconfiguring or defining a particular subnet, you can decide at that point whether you want access into that network. And the connector itself is, as Lior mentioned, just deployed as a container, most typically. And so you have very fine-grained control over exactly what subnet people should have access to, and then what rules apply inside that subnet, right? And that's I think the point that we're trying to make, is that it becomes very native to your IAC definition as opposed to being managed outside of your system. Okay. Okay, so the first Mike L. There's another question here. So let's see. His question is: you mentioned just now about not leaving open ports by various techniques. Is one of them port knocking, or else how do you wake endpoint security to open a resource onto the insecure internet? Yeah. So just go into a little more detail here. I mean, the way that our connector technology works is the following. So there's a couple of things that we can do, and I'll describe some of those. So the connector itself, when you deploy it, it's deployed with a certain set of authorization keys. And by the way, like in we have in our Terraform provider, that process is baked into that, so that you don't actually you don't have to manage the managing those keys, and the deployment is all like part and parcel of the provider that we provide. So in the deployment of the connector, those keys authorize it to access your particular instance of your TwinGate network. And what happens is that the connector at that point, it basically registers itself with our system. And that registration is an outbound connection. And so you simply need to allow, and you can limit this as needed, but you simply need to allow the connector to initiate an outbound connection to us. And at that point, that registration says that the connector is available and for routing traffic internally. What we do from there is that part of that registration process establishes its availability, is that we're then basically using, pretty standard, although of course customized for our situation, pretty standard sort of NAT traversal techniques to negotiate a connection between the client, which sits on our on the user's endpoints, to negotiate a connection between the client and the connector directly. And so there's a signaling service that sits in the middle there that negotiates that connection, and that's the first preference. And if that can't happen, then there's a fallback process by which that traffic will flow via an intermediate node. But the primary thing is that no inbound ports required, no port knocking, like no sort of tricks like that. But it is just sort of standard NAT traversal with that initial registration. All right. Any other questions? These are really good questions. Happy to answer more. Let's see. Oh, actually, so it looks like Vincent actually. It looks like we do have a clarification over automation. Okay. So I'm not. Yeah, I think it's too bad. Actually, we can't speak to people live here, but I think that the I'm happy to talk about this sort of if you can get in touch with us, Vincent, on the question of overall automation. Happy to talk about that separately. But I think the broader point I think that we're trying to sort of communicate around all this is that I think dealing with tons of complexity has led to the introduction of tools like Terraform to manage that complexity. And really, I think what we're seeing is that ability to securely access infrastructure for the right people has really been lagging. And so I think we're still really early days in terms of where this technology is going to go. And what we're presenting, today is really simply I think probably one of the sort of initial methods I think people are going to use. But one of the big benefits we've seen is that integrating that access component via IAC into the actual deployment and maintenance of infrastructure really does have massive benefits. One of which, of course, we've talked about in terms of matching access to network segments you're deploying, but also matching it over to particular users and groups that need access to particular resources, the ability to update those almost immediately, keeping infrastructure up to date, all that stuff is really, I think there's massive benefits to that. So I think we're actually okay here with questions. If there's any last questions, we'll wrap it up.
If you'd like to try out TwinGate for free today, we'd love to have you join our Zero Trust journey. You can see the product in action live by signing up at twingate.com/signup. Thanks so much for your time and hope to see some of you very soon.